Hi.
Hello. So today we want to do what is it? The or and the not, which are logic operators. Where is the document? Okay. So we want to do the or and the not. Then we move on to looping structures. So yesterday we did the and. Then we said the and, for it to be true, all conditions must be true. All conditions must be true. It doesn't matter how many conditions are there, but they must be true. I did give an example, like if you want to log into a site, your username should be true and your password should be true. So the both conditions need to be true. Then today we want to do the or. So the or, for it to be true, at least one of the conditions must be true. At least one of the conditions must be true. So I'm making, for example, I can give is like maybe you are asking of a certain family a gift. So if I go to that one there, I will need to ask, are you a family member? If you are, then I'll give you the gift. So if you're not, I won't give you the gift. So it doesn't matter if it is.
Mr. Lazarus, you are breaking.
Okay, I think maybe it's network. Um, are you hearing me now? Hello?
Yes, we can.
Okay. So as I was saying, for an or, where is my, is it not typing? For an or, at least one of the conditions must be true. For an or, at least one of one of the conditions must be true, right? So this is how the or works. So if I have an if statement like this, so the syntax for an if statement, we said it accepts a condition here, like this. Then it will accept a body here, right? So this condition, if I'm joining more than one condition with an and, all those conditions must be true. If I say maybe condition 1 and condition 2, condition 2 and condition 3. So for an if statement, we say the body only gets executed if this whole thing results to true. If you remember, I said if the condition results to true. Then yesterday I said for an end, this one, which is a logic operator, it results to true only and only if this condition and this condition is true. The same for this one, only if this condition and this condition is true. So for this result to be true, if I'm using an and, all condition 1, condition 2, and condition 3 must be true. Okay? So a condition can be anything. A condition, maybe I can check if 2 is greater than 3. Greater than is 2 less than 5. So this is true. This is the condition. Or maybe you can say if username is equals to, then you check the username. If the username that the user has entered is matching with the one in the database, and then here you can put the condition for password. If password that has been entered is matching with the password that we have in the database, and maybe the region, maybe the app is geologged. So the app needs to check if the user is in a certain region or in a certain country. So if you are in a certain country, and if your name is correct and your password is correct, then we allow you to log in. So this is how the end works. So for an or, so this is condition 1. For an or, right? If I replace and with an or, like this, so this condition only results to true if at least one of these conditions is true. Okay, so let's just put okay, let me just, before I use an if statement, let me just use okay, let me just use a print statement so that it makes sense. So if I say print like this, right, is 2 greater than 3 or 5 greater less than 8 or 10 equal to 11. So the result of this is it will check this condition. Is this condition true? This is false. 2 is not greater than 3. Is this condition true? This is true. So when it finds the true statement here, it will ignore the rest of the conditions, which is this one. Then this thing will result to true because I have found a true condition here. So if I run this, I'll get true. So the true is been found here. Then the whole thing has resulted to true. But let me just put is 15 less than. So this one is false now. 2 is not greater than 3. This one is false. This one is false. 15 is not less than 8. This one is false because 10 is not equal to 11. So if I run this now, I'll get false. So this is how in the OR operator works. All the conditions, at least one of them should be true for the whole thing to be true. Okay? So if I have this syntax here of an if statement with an OR condition, so what happens here is it is going to check condition 1, condition 2, condition 3. The moment it finds a certain condition that is true, then the whole thing becomes true. So then you can also have a combination of both. So what happens if I put an end here? Any suggestion? We did an end yesterday. What happens if I put an end here? What's the result? What's the Boolean result of this whole thing? I'm asking from your side. What do you think is the result of this Boolean value? If I put an end, we did an end yesterday. Hello.
They are still thinking.
Okay. Can we make it fast because of time? Okay, because of time, maybe I'll just chip in and do try along with you. So, like I said, from that day, execution executes from the first line going downwards like this, right? And also, when it gets to a certain line, it executes from the starting of the line going in this direction. Okay. So, when I find a print statement, the program knows that I want to print something, but what am I printing here? So it will try to print what's inside the bracket. But when it gets inside the bracket, there's a calculation being done uh, of um, of logical operators. So it will compute this. So it will compute this. It will compute it's 2 greater than 3. So this will result to it's 2 greater than 3. This is false. False like this, or is 15 greater than is 15 less than 8. This is false. This is false. And 10 equal to 11. Okay. Then the next computation will be, since I have an OR operator here, if false or false, we said for an OR for this one, it is only going to be true if this and this is, if either of this is true. But false and false is both false. So this will result to false. This will result to false, and 10 equal to 11. Then this is false, and is 10 equal to 11? No, so it's false and false. Then for an AND operator, we said it results to true only if both conditions are true. But this is false and false, so this will result to false. So this war statement here will result to false. I hope you were following. So if I run this, let me just comment this. What do I comment here? Make sure the shortcut for commenting. So if I run this, so you can see it is resulted to false. So you need to know how the OR operator works and the AND operator works. So the OR operator, we said both these conditions, at least one of these conditions has to be true. But this was false and false. So this thing resulted in false. Then this is being computed with an AND. Then for an AND, we said the left-hand side and the right-hand side is supposed to be true for it to be true. But this has resulted to false. So this thing has resulted to false. Then false and false will result in false. But if I say 10 is equal to 10 here, so let me just roll back here. So if I put 10 is equal to 10 here, so this will result to true, which is this one, right? But this side is two-way false, so it will be false and true. This will result to false. But for an AND, we said both conditions must be true. So this will result to false. So even if I remove this so that it can run, I'm still getting a false. But if I Okay, this is true. If I put is 4 greater than 3, this is true. Then if I leave it like this, so this is true and this is false. But for an or, we said it can be true only if at least one condition is true. So this is now true and false. This is true because this is the result of this true is the result of this operation. Then we have our or, then we have the result of this operation, which is false because 15 is not less than 8. But this will now result to true. Because in or we said at least one condition must be true. So this one, this true or false will result to true here. But we have an end, then we have our computation here where we have changed from 11 to 10. We are comparing is 10 equal to 10, which is resulting to true. Then this side we have a true, since we said this is a true or false here. Then if it's a true or false, it's a true. Then we have a true here. Then now we have a true and a true, which will result to a true. So let me just move this so that it can run, because these are not Python commands here. So you can see now it has resulted to true, even though this one was true and this one was false. But we have joined it with an or, and it has resulted to true because this condition is true. We said at least one condition. But if I remove this and put an end here, so it will result to false because if for an end, this one is to be true and this one is to be true. So if this one is true and this one is false, so this whole thing will result to false. Because for an end, we said both conditions has to be true. And if this result to false, we are saying false and this is true. So false and true. And we said for an end, both conditions have to be true. So this will result to false because this is false and this is true. And we are joining with an end, then the whole thing will result to false. So this is how logical operators work. Okay.
Mr. Lazarus,
So
please go back to Tony.
okay.
Okay, can you try out with 4 greater than 3 or 15 less than 8 and 11 is equivalent to 10. I think I missed on that. Yes, leave it like that. The 10 replace it with one of the 10 replace it with 11 and try to run the code.
Okay, let's do dry running first. Like I said, as a programmer, you should be able to show what the output of your code before you even run it. So let's try to dry run it. We do have an or here, right? You're following, right? We do have an or here. Then we said for an or, at least one of the conditions must be true. But for this or, the conditions that we have is this condition and this condition, right? So at least one of these conditions must be true. So I will ask, is 4 greater than 3? Can you answer from that side?
Yes.
Is 4 greater than 3? So this is true, right? So we do have our O. Is 11 less than 8?
False.
This is false. We have an end. Is 11 equal to 10?
No.
False. Then for an O, we said both conditions must be true. So we have a true here. And for an O, we said at least one condition must be true. We have the true and the false. So what's the result? If I say at least one condition, this is the condition, right? But this is the result of this condition. So we have the result of this condition and the result of this condition. And we said at least one must be true. So we have this one and this one. We have two conditions here, this one and this one. So what will be the result of this computation here?
That's true.
That is going to be true, right? So we have a true here. Then we have our end, we have our false. Then for an end, we said both conditions must be true. Both conditions, all conditions must be true. So what will be the result of this true and false? Both conditions must be true.
They're saying false.
Which is true because we do have a false here, which will result to this thing being false. Okay? Anyone who's still not following, I can do another example. Okay? Let me say A is equals to 2, B is equals to 5. Okay, let me just use integer values. So we want to perform arithmetic operations, but with logic operations. Okay.
You don't send a message, nothing say hi. And this can be temperature.
We want to see if our sum is greater than, maybe let's say greater than 10. Is A plus B plus C greater than? So this is one thing. We need to put a bracket here. This is one thing. We want to see if it is greater than 10. What will be the result of this thing? This is the Boolean value. We said the moment you see a logic operator like this in a computation, where are the other logic operators? These are other logic operators, these ones. These are logic operators. They're not equal, greater than, equal to. We use them to compare. From the word comparison, we use them to compare two values. Yeah. We use them to compare two values, right? So what are we comparing here? This is one value. This is one value. The 10 is one value. This is one value. But this value is being comprised of summation of variables, which we do have the values at the top. So we say this one will result to 1 Boolean value. So what will be the result of this print statement? Hello, for the sake of time, can you kindly make it quick, the thinking part?
They say it's false.
It's false. Okay. What do we have for 2 here? We have 2, right? Here we have 3. 2 plus 3 is 5. 5 plus 4 is 9. So it's saying it's 9 greater than 10, which is false. So if I run this, I'll get false. Okay, like this. What if I now join it with an AND? Remember, this time I'm converting if A plus B is equal to 5. What will be the result now? We do have a false here, so you don't need to recompute this. We do have a false here. What you just need to do here, you just need to compute this. Then you use an AND to compute this false. Then you join it with whatever the Boolean value of this is. Then you use an AND logic operator to see if the result is going to be true or false.
They say it's false.
False. So, like I said, just maybe it's only me. But like I said, if you see an AND, right? If n of one of the conditions tends to be false, you don't need to calculate the rest of the conditions. So the moment I had the false here, then I see an AND. Then we said for an AND, all the conditions must be true. So the moment I see a false here, this will automatically result to false because for an AND, all the conditions must be true. So I don't need to worry about this condition. Okay. But if I have an OR here, so this is false. And this will result to true if only this becomes true because this is already a false. So what's A plus B? A plus B is 2 plus 3. 5 is equal to 5. So this is true. So this is now false or true. Then we said at least one of the conditions is true. So this is true. So this will result to true. Okay, as you can see. So that's it on you get it more when you practice. I'll give you maybe at the end of this, probably not today, but at the end of this lesson, you should be able to know more about these logic operators. Then the note will just do the opposite. So if it is true, it becomes false. If it is false, it becomes true. So if I come here, then I say A is equals to C. Then I say not A. I'll get what? False. So what this does, it just gives you the inverse or the opposite of of your result. It gives you the opposite of your result. Okay. Or maybe I can say A is equals to true. You say A is equals to true, right? Then if I say here, not A is equal to 2, so we know that the result of this computation is true. This is now a comparison. So this is an assignment. This is now a comparison. So is A equal to true? So this is true. And if I say not, so it will give me false, like this. So we know that this is true, right? But if you put an end here, is A greater than 5? So this is what? False. Because our A is true, so 2 is not greater than 5. So this is false. Then we join false and false, we'll get what? False. The whole thing becomes false. And the opposite of false is true. So this one will convert the false that we have here to be true. So if I run this, I'll get true. So the note, well, how was it defined here? Okay, I do not need to open this project. So it inverts the condition. That's how the note works. It just gives you the opposite of your result. Anyone who hasn't understood how the note works, or if I have an or here, so this is true, this is false. But we said if it is a true or false, the or becomes true only if at least one of the conditions is true. So this is true. So this thing will result to true. Then we are saying not true, which is false. As you can see, this is false. So the not, it just inverts the condition, or it gives you the opposite of your result. Anyone who still has some issues or about the not end in the or?
There's a question.
So
We need
silence, I
clarity.
assume everyone.
Okay, we need clarity somewhere. Just for
Okay.
clarification, not a question. Ask. Okay, I can ask. Okay. So could you please repeat the notes? Maybe you can use another example to repeat the not.
The not Okay, let me see if I had put some examples in here. No. Nope. There are no other practical examples. But let me just like this. From the English definition of not means it means that is not the opposite of that. If I say if this is this your jersey, if it is yours, what do you say?
Not.
If it is not yours, right. So the not from the English definition just means not that. So not it just inverts the condition. Always. The not always inverts the condition. Or you can say it gives the opposite value. Opposite value. And the values that we're talking about here, we remember these logic operators, these three, these ones, the same as these ones, they result to 1 Boolean value. So if I say it gives the opposite of, it gives the opposite value. The values that we're talking about is true. The values that we're talking about here is true and false. Okay, so these are the only possible values, right? So the note, it just says if your result is false, then if you want the note of that result, your result will be true. And if your result, if it is true, then you say not my result, it will give you false. So that is how the not operator works. So it just inverts um, the condition. So if my result is true, if my result is true, then I want the opposite of my result. My result. Yes. Okay. The same if my result is false. If I want the opposite of my result, I'll just say not my result. So it will just give me true. Okay. Let me just give you an example. Like I can have my password. What's my password? My password is 123. Right. So if a user puts a password, then we want the opposite of that. So we can just say print not. Then we want to check the password. Password is equals to, maybe this user has put 1453 like this. Okay. So what will this result to? This will result to false because password is 123, but the password provided here is 14322. Then if you compare these two values, the result will be false. But if you put the note, it will just say not this, but what is this? This is false. So not false, it just gives me true. So we are just saying the opposite. So if I remove this, I'll get false, as you can see. But we want the opposite of this, then we use not. Okay. The same, if I have my password provided is 123 like this. So this results to true. Okay. But if you want the opposite, we say not like this. Still, we still don't get to how the not operator works.
We okay.
Hello.
Okay.
Okay. Okay. Let me just give maybe a practical example. The one that may not be code related. Maybe we have two human beings. We have two people, two human beings. These two people maybe they hate each other, right? So they don't like walking to town using the same road or maybe using the same commuter minibus or the same taxi or something. So I'll just need to know which taxi you are using or which road you are using. Then I'll say I will use the opposite of that in road B. So if one person is using this, since the other one hates this first person, you do a person one and person two, right? Person one and person two. Okay. So if this person one is using road A, then automatically it means person two is going to use the opposite of road A, which is road B. So what this person two is going to use depends on which road is this person using. So if this person is using road B, this person two is going to say not road B. So I'll get road A. I'm not sure if this is making sense. So we have two roads and two people. Two people we hate each other who don't like using the same road. So I just need to know which road are you using. Then I will say not that road, which means the other one. If you're using this one that I want to use, then I will automatically use the opposite of that, which is the road B. Or if you're using road B, then I will use road A. So that's how we use the inverting logic operator, which is a not. We use it for certain conditions. Maybe if by this example, maybe you get it better or not. I'm not sure. But for the sake of progress, let me just proceed. You'll get it along when you do more practice. Then moving on to looping structures. We're going to do the while and the for. Then we'll move on. There are also some other looping structures like do. We're not going to talk about them, but let's start with the for. This one. So looping structures, they allow you to execute a block of code multiple times. Okay, so all looping structures, all of them, there are some other examples that I didn't put here. There's the do, we have while, we have for. Okay, so these are some of the examples. Let me just start with the for loop. So like I said, looping structures, they allow you to execute certain lines of code multiple times. So let's have an example, like I can say print A, like this. If I run this will print A on my console, right? Are we together? If I run this, it will print A on my console. If I put another print at the bottom, this will run here. It will print an A. It will also print an A. So I will have two A's. Okay. I can print another A. Okay. So what happens if I want to print how many A's? 1,000 A's. These ones. So I'll need to write print A like this. Then I'll go at the bottom line. I'll also say print. So this is line number 5. Up until I get to line number 1,000. Just imagine how much time you are going to take. It will take longer, right? So the 4 is a looping structure that allows you to execute. So if I run this, I will have 4 A's because I'm on line number 4. I can have another one. I will have 5 A's on line number 5. But looping structures, they say no, you don't need to keep on writing the same lines of code if you want to execute the same lines of code multiple times. So that's how the 4 works. So the 4, its syntax is 4 like this. Okay. Then the next argument, you say for I in, and you put range. Let me just put it first. Then I'll explain what each line is doing. So if I run this, I will have 4 A's. Take note, I didn't write print A 4 times. I only wrote it once. But due to the purpose of the for structure, it has printed me A 4 times because of the range that I've given here. So that is the for loop. It allows you to execute all control structures. They allow you to execute same lines of code multiple times. So the number of times it depends on you, the programmer, what you define, how many times you want to run that code. For example, here I said I want to run this line of code 4 times. So this line of code will be run by my compiler 4 times. When it runs for the first time, it is printed here. Then it has run it for the second time, it has printed it here. Up to until it has executed my lines of code 4 times. Same, so the body of the for loop, same with an if, all control structures and all condition statements. The body is up to you. How many lines of code you put in here? It's up to you. I can have print B. So what this will do, it will print an A and a B first time, then it will go to index number 2, it will print a B. So this will print 4 A's and 4 B's, but with an A, B, A, B, A, B. So if I run this, you can see I have A, B, A, B. So this is one loop, second loop, third loop, fourth loop. Then my program is ended. So this is how the for works. So its syntax is to say for, then here you put a variable, any variable you want. Like we said, variables, so they have to fall under those variable naming conventions. So this is a variable. It doesn't matter if you use it or not, but you have to put it. So this will represent what is called an index. An index just tells you where are you at now. But here we are not accessing it yet. But let me just print it so that you can see which index are we at. If I print I here, if I run it, you can see I'm at index 0, index 1, index 2, index 3. If you do remember indexes, that's what I said that day when I had my name like Lazarus. Then I said indexes, they started 0 in computer. So I said 0, 1, 2, 3, 4, 5, 6, 7. So my name ends at index 7 and it starts at index 0. Right, yes. So, but my name is 7 indexes. These are called index. The spelling for index is this one. That's what I'm saying. It just says my name is 7 indexes, but how many characters my name is? It has a length of 2, 4, 6, 8. It has 8 characters, but it will have 7 indexes. Why? Because my index, they always start at 0. That's why you saw a 0 here. So here I've printed I. So this was the first loop, which is this one. When it finishes executing whatever that is on your board, so I can have any number of arguments, like up to statement n, like this, right? So when it finishes executing whatever it is in the board, it is going to come back and start again, printing the same statements, but only that this time the index is incremented, so it will start at index 0, which is saying I'm printing this for the first time. Then when it comes back, now index will be 1, which means that we are at the second execution. Then you need to go to third time, fourth time. So if I give a range here, my uppermost value will be 3, and my leastmost value is 0. I'm not sure if you are following or if there's anyone who is left behind on this, because we want to do a practical example. Okay, but this is the syntax for 4. So if I am to write a syntax for printing maybe 20 numbers from 0 to 20. So like I said, index, they always start at 0, right? But now we want to print 20 numbers. Okay, if you want to print 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 20, like this. So what we say here, so this is our starting value, right? But here our starting value is 0. So this is 0. Then when it goes in the second iteration, our next value will be 1. But here we have already printed 1. So what you do here is you increase your starting value inside here. So instead of printing an I, you now print an I plus 1. So what this does is our first iteration will be 0, which you say here 0, then it will add 1, so which is 0 plus 1, which is a 1, which is this one. Then we need to iterate for the second time. This time our I is 2, but our I is 1, because when we started we said I is 0, then 0 plus 1, which is 1. Then now I is 1, then we say 1 plus 1, which is 2, is this one. Then the second iteration, our I is 2, then we say 2 plus 1, which is 3. So this will print 20 numbers. So we will go up to 19 here. Okay, so if I run this, we started from 0 up to, okay, we need to go to 20, not 19. Because on the 20th iteration, our I will be 19. That's when it says 19 plus 1, which is 20. So now we should print 20 numbers like this. So I've written it in a smart way, but somebody can just come and say print 1, print, okay, 2, print like this, 3, okay, and so forth up to print 20, which means this person is going to have 20 lines of code only to print 20 numbers. But how many lines of code do I have here? I only have 2 lines of code, but I'm achieving the same task that this person is doing. So for is a control structure that helps us to execute same statements multiple times. Same statement, not different statements, same statements multiple times. Or same block of statements, but the key term here is multiple times. It's multiple times. So this is how the for loop works. So in this example, I put this. Okay, why is it failing to copy here? Okay. So if I come here and I put it here, so what this will do, so this is a body. The same as for if the body has to start four spaces after the for loop where the f is starting. So my f is starting here. So this one is the 1, 2, 3, 4. Or I can use space. I can use a tab to tell my program that this is the body for this for loop. So if I run this, so this will print this 4 times, 5 times. Then this is my I. My I is starting at 0 as always. Like I said, the index always start at 0. So it was saying this is the first iteration, second iteration, third iteration, fourth iteration, fifth iteration. So this is how the for loop works. Any questions? I think for today we'll do the for, then the next lesson we'll do a while. Then after that we'll do more practical examples. I think after a while, it is followed by what? Nested conditions, nested loops. I will talk about this after you've understood how the for works first. So any questions on the for loop? Any questions?
None.
None. Okay. From that side, can you write me a for loop to print from 1 up to 50? You have 2 minutes to write that. From 1 up to 50, then run it, then tell me when you're done. I'm giving you only 2 minutes, so at 1 past 2, you should be done. At 1 past from that side, you should be done. Quindi Berra ma microservice.
Ada DigiSkills. Ada lesson DigiSkills. Unaweza kuwa na party yako.
Gani? Ya bo. Ini 5 minutes in the business. Será con. Okay, time is up. I'm sure I finished the code. So I'm just going to write it from my side. If you haven't, just copy what I'm going to write here. So I want to print 50 numbers. So just say for I in range 50, and then I'll print I. But we want to print from 1 to 50. This will print from 0. So I'll need to add the one here. So if I run this,
We can't see your
you can
screen.
see I have mine.
You are not sharing your
You can
screen.
see my screen.
Mm.
I am, but maybe let me just share again. How about now?
Yes, we can.
So the keyword that you just need to know here for the for loop in Python is it makes use of range. This is an inbuilt function, this one. So you can see if I click it, if I click control, then I move my cursor to the word range. I'm clicking control. Then if I click this word, it will put here in, it will underline the word. This tells me that this is an inbuilt thing. The same for this, the same for this. All reserved keywords and all inbuilt things. If you put if you click control and over your cursor to that word, it will give you a highlighting or an underline. Then if you click it, it will take you to the class for that word. So this is how the range works. So it's just a sequence. Then it accepts an integer value, which is called an upper bound. So it accepts. We'll talk more about this range in our next courses. Also, the range can accept two arguments, which is lower bound and upper bound. Let me see if there is a combine for that here. I'm not seeing it, but if from 50 to 100, okay, it's still not. By this time, let's see if it runs. Okay, it will run. By this time, it will execute. But we'll talk more about this range function. So if you don't specify the syntax for range, is I can say range, then it, inside there I'll put an upper bound. Upper bound, okay. If I don't specify the lower bound, this will only be an upper bound. But if I put two integer values, so this will be lower bound, then the next one will be upper bound. Can you just jot this down? We'll talk about this more often. Now, can you just jot this down and remind me in our next lesson? We'll talk more about how this range works. I'm seeing that in my notes I didn't put it. I didn't explain how the range works. Okay, but like this, there's a range with one argument, then there's a range with two arguments. So this one is one argument. If it has one argument, like this 5 is an argument, then this is an upper bound. If it has two arguments, this is a lower bound and this is an upper bound. So we'll talk more about this. Kindly just remind me in our next lesson. I'll explain further how these limits work. So somebody can say lower limit, just terminology that you may use. Somebody can say lower limit and this is upper limit. So this is just where am I starting from and where am I ending here. So okay. Then there's also the one with third argument. I'm not sure why their class is not giving me that. Okay. Then if it is a third argument, this one is a step. We did talk about range, didn't we? Oh, we talked about it when we were doing slicing. When I said you say lower limit when we were doing slicing on string manipulation, lower limit upper limit, then you can put a step here. This was on string manipulation when you were doing slicing, right? The same technique was also used on range. This same technique is also used on range. When you specify your lower limit, your upper limit, and step. Okay, so we'll talk about this more often, but it works the same. So I can say from okay, I can say from 10 to 20. So this will loop 10 times, but if I put a step of 2, so this will loop 5 times. So if I write here, okay, so this is looped. This is looped 1, 2, 3, 4, 5 times. Why? Because I've put a step here, a step of 2. But what's my range? My range was supposed to iterate 10 times because I'm starting from 10 to 20. But since I put a step of 2 here, so I'm going to loop 5 times here. Then my starting value is 10. Since I've specified the lower bound, so my starting value will be 10, 10 plus 1. So that's why it is printed 11 here. So if you don't specify a step, or if I put only upper bound and lower bound, this will print 10 times, starting from 11. You can see I started from 11, and I've printed 10 times here. And also, if I put a step of, 2, it will just jump 2 times from 10, from 11, 12, 11 to 13, from 13 to 15, and so forth. Then I can also have my upper bound here and my lower bound here. Then I can also do a step of negative value. It will still run fine. Let me just print the I here, not the I plus 1. Okay, where is it clicking? Okay, as you can see, I've printed my values, but this time I'm printing from the uppermost going downwards. Rather than if I use a step of 1, I'll print, if I put a step of 1, it will print from 21 to 30, not from 30 to 21. So if I remove this, it will print from 21 to 30. And if I run it, okay. Okay, so the step of, so if I'm using the step of a positive value, the upper bound should be the one that will be the second argument. So as I had earlier, this. Okay, so if I'm using a positive value as my step, I should have my upper limit in the middle here and my lower limit here. But if I'm using a step of a negative value, which is a negative step, then my upper limit will go here, then my lower limit will go here. Okay, so this is how it works. So if I am putting a step of positive value, if it is like this, it will work fine. Why? Because it will fine because I have a step of a positive value. Then if it is a positive value, my step here, my lower limit should be the one starting, and my upper limit should be the one. If I run this, it will work fine. As you can see, it has printed something here. But if I put a negative here, then if I try to run it, it will print nothing because it's trying to start from 50 to 100, but going backward. But 50 is not greater than 100. So it will fail. But if I put 100 as my upper limit and 50 as my lower limit, then this will print from 100 going back to 50. Like, so I increment one is, so I do not need this. It works, but basically that's how it works. Lower limit to upper limit in your step. If it is a negative, maybe if I say print 100 values from 600 going backwards. So you just need to say 600 here. Then if I put a negative value, so it will print. But this will print from 600 back to 51. So if I move this, it is printed from 600, 500 something, 400 something, 300 something, going back up to it is up until it is reached 50. Okay, this is quite long. Okay, so this is how the range works. Okay, up to it is reached 50. Then in our next lesson, then we are going to do a while loop. But for the for loop, I think that's it. So if there are no any questions, I think that marks the end of our lesson.
Any question, any comments? Okay. Mr. Lazarus, there's no comment or question from our end, so mine is to thank you for today's session. And it is our belief that the learners have also understood today's lesson on loop for loop. And we are looking forward to tomorrow's session on while. If there's any clarification needed, especially on the comparison and logical operators that you mentioned earlier, the and, or, and not, including the for loop, we will let you know. And I'm sure the learners have your contact. They can easily reach out to you in case of any clarification or any question needed.